Now to start solving or finding coterminal points, it can always be found by starting with the idea of 2 pi. Since one full circle is 2 pi, any point, if you add 2 pi to that initial point that you already have, or really it's the original terminal point, the initial point is always 1, 0, but basically if you take any point, add a distance of 2 pi, you're going to come back to the exact same point, because 2 pi always means one full circle. And the definition of coterminal points are, well, two terminal points in the same position, but I went ahead and defined it here as the same point defined by two different t values. Like in the previous example, we got to the point 0, comma minus 1 by going counterclockwise 3 pi over 2 distance. But we could also have gotten to comma minus 1 by going negative pi over 2 clockwise, because clockwise is negative, counterclockwise is positive. So 3 pi over 2 this way, negative pi over 2 this way. And those were coterminal. And notice that 3 pi over 2 and pi over 2 together make 2 pi, or really the difference between them is 2 pi, because one is negative. But like let's focus on the next example. It says find a few more values of t which are coterminal with 5 pi over 2. What is the terminal point associated to t? But the trick, this is kind of the moral of the story. Uh, Adding or subtracting 2 pi will give you another coterminal point. So let's go back to our whiteboard. So say we're starting with t is equal to 5 pi over 2, and we want to know where is this, or what is the location here. If we add or subtract 2 pi, it will be in the same position. So notice since this fraction is bigger than 2, 5 halves, or, well, ignoring the pi from it, I really mean, but let's just say I'm going to choose to subtract 2 pi, but you could either add or subtract, but subtracting 2 pi will help us recognize this value as something we already know. And basically, this should be in the same position. And notice it's not technically the same because it's not the same value of t. I'm changing it, but it will be in the same position, which hence is the idea of coterminality. But basically, again, in order to do this math, need a common denominator because I can't just subtract a fraction from a non-fraction. So if I multiply top and bottom by 2, that would give me 4 pi over 2 equal to 2 pi. And now that I have a common denominator, that would leave me with 5 pi minus 4 pi all over 2. And to add and subtract values of pi, it works just like um, combining like terms. So just as if it was 5x minus 4x, 5 pi minus 4 pi would just be 1 pi, or pi over 2. But basically, what we'd be left with is pi over 2. And what the conclusion here is that's coterminal to the original thing I started with, 5 pi over 2. Hence, they're in the same location. Now, trying to understand, the implications of what we just figured out. Well, we know that pi over 2 is at the top because that's one of our fundamental points on the unit circle. A quarter of the way around is the distance pi over 2. What we've concluded is that 5 pi over 2 is in the same location. Or how I could imagine that is if I added 5 pi over 2 to it, or did one complete full more circle, that would be 5 pi over 2 for the full distance from initial point, going around a quarter of the way and a whole another time. But anyways, 5 pi over 2 is in the same location. It has the same terminal point as pi over 2 because they are 2 pi apart. And this is the idea of periodic phenomenon that I talked about in the intro. Periodic phenomena are also often modeled by these trigonometric functions because, like going around a circle, it's going to repeat itself. Those terminal points will repeat every 2 pi, which is often what's referred to as the period of the unit circle, or the period of generic trigonometric functions, because that's what makes a full circle. But in the example, let's just make sure we're answering the full question. It said find a few more values of t coterminal with it. That was one. So conclusion there is that, pi over 2 is coterminal to 5 pi over 2, but there are more. There's really an infinite number because the idea is I could go another 2 pi and it will give me the same point, or another 2 pi, another 2 pi, another 2 pi. I could keep going and going and going and going and going, and I could find more and more and more coterminal points. So I start off by subtracting 2 pi. We could have also started off with 5 pi over 2 and added 2 pi instead, and that would give us another coterminal point, basically another rotation beyond what we had initially. Or it's easier just to add 4 pi over 2, because as we As I said a second ago, you can't add it when well, you can. It's not, it's easier to have a common denominator, but if we add 4 pi over 2, that's equal to 2 pi. That would leave us with 9 pi over 2 as another coterminal point, which would just be taking 5 pi over 2, which was the distance in black plus purple, and going around again. And that total 2 spins plus is going to be 9 pi over 2, and so on. I could keep adding 2 pi, and that would give me more and more and more. So the next one, well, if adding another 4 pi over 2 would be 13 pi over 2, or 17 pi over 2, so on, so on, so on. We get more and more. Or we could subtract 2 pi over and over and over again to get more and more and more the other way, going counterclockwise. So how I kind of visualize it in my mind is adding 2 pi is doing a full circle counterclockwise, subtracting 2 pi counterclockwise. Regardless, I'm going to find coterminal points.